So here we are with the second section of the Section 8 test, so page 2 of the Section 8 test. It's numbers 12 through 21. Feel free to fast forward to the problems you're specifically looking for. I'm going to take my time and try to explain them pretty clearly, so it takes a little while to get through some of these. All right, so this next problem, or 12 and 13, let me zoom in on them just a little bit. If AC equals 26, find BC. All right, so here's AC, and we're looking for BC. So this one is a little bit easier if I pull this triangle out of the square, I think. And I did not draw that very well. All right, so this corner of the square from here to here, this whole thing, AC right here is 26. And we're looking for BC, which is right here. Okay, so this is a right triangle, obviously. And on any square, we know that these corners are broken up into equal parts. So this is 45, and so is this. And it's like that on every corner, right? So what I'm looking at right here with this triangle is a 45, 45, 90 special right triangle. And the 45, 45, 90s work like this, if you don't remember. Man, I cannot draw one of these today to save my life. All right, whatever the leg is, let's say it's 5, then the hypotenuse is just the leg times radical 2, 5 radical 2. That's if you're going from a leg to the hypotenuse. But if you have to go from the hypotenuse back to the leg, like you know the hypotenuse and you're trying to figure out the leg, then you have to do that in reverse, which means you're going to have to divide by radical 2. And that's what we're going to do on number 12. We're going to take 26 and we're going to divide it by radical 2. Okay, I don't see an answer like that, do you? Nope, don't see one. All right, so I know that we don't like having these radicals in the denominator, so we're going to rationalize it by multiplying top and bottom both by radical 2. And we're able to do that because this fraction right here is equivalent to 1. Anything divided by itself is 1. And when you take anything and multiply it by 1, you're not changing its value. You may be changing how it looks, but its value is still the same, so it's an equivalent fraction. So let's multiply straight across here. We get 26 radical 2 over, and then radical 2 times radical 2 is radical 4. The square root of 4 is 2. Anytime you square a square root, the square and square root cancel out and you're left with just the number. Now look here, we can divide 26 by 2 and get 13. So our answer is 13 radical 2, which is B. All right, if the measure of angle ACB, so ACB, is equal to 11x minus 32, find the value of x. Well, humorously, we've already written in there that angle ACB is equal to 45 degrees. So I know that this is 45 degrees. So let's see, we're going to do 13 here. And 11x minus 32 is equal to 45 degrees. Add 32 to both sides. You get 11x equals 77. Divide through by 11, and you get x equals 7. And the question up here was, find the value of x. And I did that, as opposed to tell me the measure of the angle, which would have been pretty easy because these are either 45s or 90s, right? All right, so the answer here was 7. All right, number 14. Okay, number 14, find the measure of angle P. All right, so this is a trapezoid. It's not an isosceles trapezoid, but a trapezoid all the same. And I know when I'm looking at the bases and I have them top and bottom, then the left side angles are supplementary and these right side angles are supplementary. So since we're working with these two right here, then if I add these two together, they're going to equal 180 degrees. So here we go. 7x plus 31 plus 21x minus 19 is equal to 180. Okay, Combine like terms here, and we get 28x and 31 minus 19, which is 31, 21, 19, 12. And this is equal to 180. Subtract 12 from both sides, and you get 28x equals 168. Divide through by 28, and we get x equals 6. All right? It didn't say find x. It said find the measure of angle P. And angle P is this right here. So I'm going to plug 6 back into 21x minus 19. So 21 times 6 minus 19 is 107, which is answer D. There we go. All right, let's look at number 15. Find the measure of angle T. All right, so number 15 is an isosceles trapezoid. We know that because of these markings here. Parallel, one set of parallel lines, and the two legs are congruent. And isosceles trapezoids, their base angles are congruent to each other. And these base angles are congruent to each other. They're different than these, but congruent, congruent. So I can set these equal to each other. All right, so here's number 15. So 9x minus 17 is equal to 4x plus 28. Subtract 4x from both sides. 5x minus 17 equals 28. Add 17 to both sides. 5x equals 45. Divide through by 5, x equals 9. All right, 15 doesn't say find the value of x. It says find the measure of angle T, which is down here. And I don't have any clues for that one yet. So I'm going to have to plug 9 back into one of these two so that I know what the angle measure is. So let's plug it in right here. This 9 times 9 minus 17 that we've got going on here. 9 times 9 minus 17 is 81 minus 17, which is 64. Okay, so, and look, ooh, 64 degrees. But be careful, because that's the measure of angle Q. This is 64 degrees. This one's not 64. In fact, look at it. That is looking like an obtuse angle. These, I would eliminate both of those answers right at the beginning, thinking that probably my picture is fairly accurate, in which case it would have to be one of these two. Beware of this kind of trap, right? So there's 64. These two together are supplementary. They're going to total 180. So now I need to do 180 minus 64 to find that angle, which is 116 degrees right there. All right, number 16. Find the measure of angle J. Again, they gave us one that they didn't give us any clues for, so we have to use these and then figure that one out. Now, what I do know about this is it's an isosceles trapezoid. These legs are equal, and because it's isosceles trapezoid, this is congruent to this. So if I can figure out what angle K is, I have what angle J is. These two are congruent to each other here. These two are supplementary. So these two are supplementary because these are the same, right? So these supplementary angles here, if we just add them together and set them equal to 180, we'll be on our way. So here we go. 11x minus 18 plus 3x plus 16 equals 180. Okay, collect like terms. 11x and 3x is 14x. Negative 18 plus 16 is minus 2 equals 180. Add 2 to both sides. We get 14x equals 182. Divide through by 14, and we get x equals 13. All right, so I know x is 13. So I'm going to plug x back in. Remember, if I know what angle K is, that'll tell me what angle J is, which is what I'm looking for. So all I have to do is plug this 13 back into this one. So 3 times 13 plus 16, which is 39 plus 16. And 39 plus 16 is 55. So angle K is 55 degrees. That means angle J is also 55 degrees, and that's what I'm looking for. And there's my answer. Notice the 13 was there as a distractor. Be super careful about those. All right, number 17. If BD, so that's one of the diagonals of an isosceles trapezoid, if BD is 8x minus 27 and EC is 2x plus 33, find what the length of BD is. Okay, and remember, isosceles trapezoids, their diagonals are congruent, so they're equal to each other. So that's what we're going to do for number 17. We're going to write 8x minus 27 is equal to 2x plus 33. Subtract 2x from both sides. 6x minus 27 equals 33. Add 27 to both sides. 6x equals 60, which is a great number when you're working with 6. Divide through by 6, and you get x equals 10. Okay, x equals 10. Hey, there's that answer. Well, stop. What have we been talking about the whole entire time? Find BD, not find the value of x. See, I see it there, but I gotta be careful. BD is 8x minus 27. So I need to plug 10 back into 8x minus 27 because that is the length of BD. All right, so that is 80 minus 27, which is 53. 53. There's our answer. All right, number 18. Find ST. Okay, here we have a mid-segment of a trapezoid, and what we've learned about the mid-segments of trapezoids is that they are the average of the two bases. So if you add up the two bases and divide by 2, you will get the mid-segment. Also, if you think about it, if the average of these two is equal to 29, that means that if we straighten this thing up and made it into like a rectangle, both bases would be 29 and the middle would be 29, and that would be a lovely thing. And what that would do then is say adding this with this would double how long that is. If you can picture it, let me see if I can do this. Shut that off. Okay, if you picture this length right here plus this one right here. Okay, so I've added those two lengths together. That's how long it is equal to this one twice. Did you see that? There you go. So if you double that middle one, it's going to equal the sum of those two. So there's a couple of different ways you can look at doing this one. You can set it up as 10x plus 5, and I'm going to write that. 10x plus 5 plus 8x minus 1 divided by 2. That's finding an average of the two bases and set that equal to 29. But what I just showed you also is that just adding these two together equals double this thing right here, right? So that's, and algebraically, that is multiplying both sides by 2 to get rid of this. So the sum of these two, 10x plus 5 plus 8x minus 1, is equal to 2 of the mid-segments, which is 58. But you can just skip right over this whole thing if you remember that the two bases added together is double the mid-segment, right? So you double this and set it equal to those two. All right, now let's do the solving for x. Combine like terms, you get 18x plus 4 equals 58. Subtract 4 from both sides. We get 18x equals 54. And divide through by 18. And you get x equals 3. Okay. So x is 3, but remember we got to go back and find out what we were looking for. We're looking for the length of ST, and ST is 10x plus 5. So I'm going to take that 3 and plug it right in here for 10x plus 5. And that is 30 plus 5, which is 35. There it is. All right, let's look at number 19. If WXYZ is a kite and XZ, okay, we're looking at the diagonals of a kite. Stop, let's talk about the diagonals of a kite. They are perpendicular to each other. This one right here is bisected by this one. This one is not, so this is not equal to that, obviously. But this piece is equal to this piece. I know that. And these two angles are bisected, but these two are not. So there's a few things to remember about diagonals of a kite. XZ is 16. So if XZ is 16, that means that both of these sections are 8. And WR from here to here is 6. Find WX. That's this piece right here. Okay, so I'm going to ignore all of the kite except for that little corner right there. What is that? That is a right triangle. Right? We have a right angle there. We know that this leg is 6, we know this leg is 8, and we know that we are looking for the hypotenuse, which we're going to call x. All right, this is a straight up Pythagorean theorem problem where you do 6 squared, leg squared plus leg squared equals hypotenuse squared. 36 plus 64 equals x squared. These two add up to 100, which is x squared. And now you square root both sides to get rid of the square, and you get x is equal to 10. So this side is 10. That's what we were looking for. All right, number 20. And we have another kite here. If FGHI is a kite, find the measure of FGJ. All right, so let's look for FGJ first. There it is right there, FGJ. This is what we're looking for. And we talked about kites. We said at the head and the foot of the kite right here, the diagonal breaks it up into 2 equal angles. It bisects the angle there. Same up here. These two don't, but these two pieces of the diagonal are congruent. So there's lots of things. What we need for this one is that these two are set equal to each other. Also, the other thing about the diagonals of a kite is that they meet at 90-degree angles. So they are perpendicular to each other. All right, so let's go ahead and set these two equal to each other and find out what x is equal to. So we get 5x minus 1 is equal to 2x plus 11. Subtract 2x from both sides, and you get 3x minus 1 equals 11. Add 1 to both sides, and you get 3x equals 12. Divide through by 3, and you get x equals 4. Okay, plug that back in to find out what this angle measure is right here. Either one, because they're both the same, right? So we're going to do 2 times 4 plus 11. That's 8 plus 11, which is 19. So what we just found out is that this angle over here is 19 degrees. We also know that this angle is 90 degrees, and we're looking for this one. And altogether, they have to equal 180 because it's a triangle, right? So if 90 of it is already here, then these two angles must total 90. So let's do 90 and take away the 19 we already know right up here in this corner, and we get 71. So this must be 71 degrees if that one's 19 and that one's 90. And 71 degrees is right there. There you go. And last problem is number 21. If WXYZ is a square, okay, think about what you know about squares, and WZ is 27, so WZ is 27, find ZY. All right, that's a square. If you got this one wrong, I'm going to assume you read it wrong because you all know that squares have congruent sides. We've known that for a long time, right? So if this is 27, that's got to be 27. That's your answer. There you go. All right, that's all of the questions on the Section 8 test. If you needed any from the first side of the test, that is a different video, so you can go back and look at that one. I hope that was very helpful for you and that you will do much better on the retake. See you later.